Calculus was an incredibly powerful tool that was developed in the 1600s by Sir Isaac Newton and Gottfried Leibniz as a way to more quickly and easily solve a host of mathematical problems that were challenging Enlightenment mathematicians. Before the development of calculus, geometry and algebra allowed mathematicians to work with idealized, unchanging shapes and concepts. However, the real world is a lot more complicated, and mathematicians needed tools that would let them analyze messy, changing mathematical objects. So what calculus really is it's really the mathematics of change. And we're going to start off by doing a little table showing pre-calculus versus calculus, how they're similar and how they're different. So pre-calculus, these are idealized, unchanging objects. Whereas calculus deals with more realistic, changing objects. And objects here can mean anything. It can be a concept, it can be a shape, anything. So in a similar vein, pre-calculus is dealing only with the slope of a straight line. So for example, if we have a little line going off like this, then we know that from one point to another point, this distance we call the change in y. This distance we call the change in x. And then we know that the slope of the line, a change in y, over change in x. Change in is an awfully long thing to write, so this is sometimes also notated as delta y and delta x, with the delta meaning change in. We know this all the way back from Algebra 1 as rise over run, same idea, rate of change. However, calculus deals instead of with the slopes of straight lines with the slopes of curves. So for example, imagine we have something like this. At this point right here, we're trying to figure out what the slope of the curve is. And we can't do change in y, change in x the same way we did here because we can see that this is curved. The slope is changing as we go along the curve. This single point is so small that we can sort of imagine sort of an infinitely small change in y over change in x right here. But we can't really see it. What we have to do is sort of expand this curve and sort of continue it as if it were a straight line. This is called a tangent line. And once we have that tangent line, now we can actually see our change in y over change in x again. The idea is the same for finding the slope of a curve as it is for finding the slope of the line. The difference is that in calculus, the changes in x and the changes in y are infinitely small. These infinitesimal changes, they're actually called differentials with a d, have their own notation. They're sort of a dy and a dx. And so when we're looking for the slope of a curve, at a particular point, it's still change in y, over change in x, but it's now the changes in the tangent line. This is going to be notated dy dx. Delta over here is the Greek letter for d. This is an uppercase delta. So a lowercase d is basically saying we're representing the same concept, just a lot smaller. Okay, another change for calculus versus pre-calculus. Pre-calculus deals with a constant, or average, speed of motion. Calculus deals with varying, or instantaneous, speed of motion. So if we imagine that we have a little person here, and this little person is running along, in pre-calculus, what we can do is we can find their average speed by saying from this point, I'll figure out what their position was and what time it was at this point. And then we say, okay, I'm going to find their time and their position at this point. And I'm going to find their average speed by finding change in position over change in time. In calculus, we've got the same little person running along, but now we can find their instantaneous speed using something called the derivative. And I'm going to write down this symbol here. We're going to learn what it means later on. It's not going to make a ton of sense right now, but that's okay. We're just going to be using the derivative to find at a single instant what's their speed at that instant, rather than having to figure out average speed over a length of time. It's again that idea of being instant. So this is how fast the runner's position is changing at that instant. The final piece is that pre-calculus allows us to find the area and volume of regular figures So that's like finding the area of a circle, pi r squared, finding the area of a triangle, 1/2 base times height, finding the area of a rectangle or a square, length times width. Those basic formulas that we've worked with. Calculus, however, lets us find the area and volume of irregular figures. So for example, let's say we've got this really weird shape, and we've got some function for it, f of x, and this is x, and we want to find the area under this shape from A to B. Calculus permits us to find this weirdo funky area using something called the integral. And there will be more on this notation coming later. But this is the basic idea, repeated over and over, is that pre-calculus lets us do these sort of idealized, not very realistic things, whereas calculus permits us to do much, much more in terms of working with the real world and working with things that are varying and changing and irregular.